In parts of the Middle East, the water coming out of your tap never touched the ground. It didn't come from a river. It didn't come from rainfall. It came from the ocean. That fact alone tells you something important. Entire modern cities now exist in environments where natural fresh water simply isn't available. And yet they function. Homes have running water. Hospitals operate normally. Industries scale. All of it depends on one thing: desalination. Most videos stop at the technology. They explain membranes, pressure, and pipes. This video isn't about how desalination works. It's about why desalinated water is expensive not on your bill, but in the systems that keep it flowing. Because behind every glass of water is an energy equation, a financial structure, and a long-term risk that rarely gets discussed. The Middle East is one of the most water-stressed regions on Earth. It holds roughly 6% of the world's population and less than 1% of its renewable freshwater. Rainfall is scarce and unpredictable. Permanent rivers are rare. For centuries, cities here survived by carefully managing groundwater and seasonal flows. Water scarcity wasn't a crisis. It was a limit. That limit broke in the last half-century. Population growth accelerated. Urban centers expanded rapidly. Agriculture drew heavily from underground aquifers. By the early 2000s, groundwater extraction in parts of the region exceeded natural recharge by several 100%. Aquifers that took thousands of years to fill were being depleted in decades. Governments were left with a hard choice: limit growth or engineer water. Desalination is often described as a technology, but in practice, it's an industrial system. Modern desalination plants don't operate occasionally. They run continuously 24 hours a day. Reverse osmosis plants force seawater through membranes under extreme pressure. Thermal plants boil seawater using heat drawn from power stations. Either way, these facilities are designed for constant output, which means desalination doesn't supplement water supply. It is the water supply. Once cities depend on desalination, water availability stops being seasonal. It becomes a question of engineering performance. And performance depends on one thing above all else: energy. Desalination is energy-intensive by design. Producing a single cubic meter of fresh water requires several kilowatt-hours of electricity. That number doesn't sound dramatic until you scale it to entire cities. Some desalination plants consume hundreds of megawatts continuously. In certain Gulf states, water production accounts for a significant share of national electricity demand. For decades, this reality was hidden by cheap domestic fuel. Oil and gas made water feel effortless. But energy markets are volatile. And as populations grow, water demand becomes increasingly tied to global energy dynamics. What looks like a water issue is actually an energy dependency. If desalinated water is so expensive to produce, why doesn't it feel expensive? Because most consumers never see the real price. Across much of the Middle East, governments heavily subsidize water. In some cases, covering more than 80% of production costs. Energy subsidies absorb fuel volatility. Public budgets absorb infrastructure depreciation. Water bills stay low even when costs rise. But subsidies don't eliminate cost. They relocate it. From households to state finances. From the present to the future. Desalination produces fresh water, and something else: concentrated brine. For every litre of drinking water produced, more than a litre of highly saline waste is discharged back into the sea. This brine is warmer, saltier, and chemically altered. In enclosed seas like the Gulf, dilution is limited. The effects don't appear immediately. They accumulate. Marine ecosystems shift quietly beyond headlines and political cycles. There's a deeper irony here. Desalination helps societies adapt to climate stress, but it also increases energy demand. Globally, desalination already emits tens of millions of tons of carbon dioxide each year. And demand is growing fastest in the regions warming the quickest. Renewables help. But water demand doesn't pause at sunset. This creates a feedback loop that's difficult to break. Once water becomes engineered, it becomes strategic. Most major cities store only a few days of water. Desalination plants are centralized, grid-dependent systems. A short disruption cascades quickly. Hospitals, food supply, public order. This is why water infrastructure is treated as a national security asset. So why is Middle Eastern water expensive? Because it's no longer a natural resource. It's a technological service. And services depend on systems that must remain stable. Desalination works, but it reveals a pattern that extends far beyond water. We solve scarcity by engineering past nature's limits. And in doing so, we create dependencies that cannot fail. The real cost isn't the water. It's what happens when the system stops. Stay curious, stay prepared, and stay aware of the future before it arrives.